Hello everyone, welcome to the physics studio. And in this video we are going to look at the minimum speed which is required to clear a cylindrical wooden log. Alright, so what I have drawn is the cross-sectional view of the wooden log, though it is cylindrical, but if you look at its cross-sectional view it will seem to be a circle, correct? So now let's say we have a particle here and we want to project it in such a way that it clears this wooden log. So we have to find what can be the minimum speed for doing so. Okay, what can be the minimum speed of projection for doing so. So actually I could think of three cases, so I have drawn all of them. In the first case, the particle is touching the wooden log at 2 points. In the second case, the particle is touching the wooden log at a single point, and that point is the highest point of the wooden log. In the third case, it is again touching the wooden log at a single point, but that point is not the highest point of the wooden log. So first of all, I would like to compare between case 2 and case 3. So clearly we can see that the max height reached in case 3 is greater than that in case 2, and also the radius of curvature attained at any point of time, let's say at the max height, the radius of curvature at the max height in the case 3 is greater than the radius of curvature attained at max height in case 2. So by looking at these two things, I can conclude that the velocity requirement or the speed requirement in case 3 would be greater than that in the case 2. So we can easily abort case 3 from here. So now we just need to compare between case 1 and case 2, correct? So let's do it first for the case 1. So I have drawn it again. So particle has been thrown, let's say with the initial velocity v0 vector, and it touches the wooden log at 2 points A and B, and v vector is the velocity vector when it touches the wooden block at point A. So now if we just look at the trajectory from A to B, then we'll find that it is something like ground to ground projectile, right? Just look at the trajectory from A to B, so it seems to be like ground to ground projectile, right? And just by doing some geometry, let's say if I take this angle to be alpha, then this angle will again become alpha as these two triangles are congruent, and this is the radius of this wooden log, so definitely this side will become r sine alpha, and as congruent triangles are there, so this side will again become 2r sine alpha. And eventually I can also say one more thing, that if this is 90, this is alpha, this angle will become 90 minus alpha, and again this angle will become alpha. Okay, so now if we observe only the trajectory from A to B, then we'll think we can see that v vector is actually the velocity of projection. If we just observe A to B, alpha is the angle of projection and 2r sine alpha is the range. So applying the formula of range for the ground to ground projectile, which is the range is 2r sine alpha, we can equate it with the formula. Formula is what? 2, the projection speed square, so it is 2v square, and the projection angle is alpha, so I can write sine alpha cos alpha by g. I'm just applying the formula. So after doing calculation, what I'm getting v square equal to rg by cos alpha. Fair enough. So we have got it. Now I'm just thinking of relating v and v0 somehow. So for doing that, what I've done, I have used energy conservation. So I can write change in kinetic energy is equal to loss in gain in loss in kinetic energy is equal to gain in potential energy, you can write, or you can also write that the change in kinetic energy is equal to work done by the gravity. Okay, so half mv square minus half mv0 square, okay, half mv square minus half mv0 square is equal to minus mg r 1 plus cos alpha. Now this is the work done by gravity, as the particle is moving upward from here to here, it is going upward, therefore the work done by gravity will be negative, as well as this height can be written as r plus r cos alpha, right? This is r, and as this is r and this angle is alpha, this small height can be written as r cos alpha. Therefore this entire height will be equal to what? Taking r common, it will be r under bracket 1 plus cos alpha, correct? So on solving this energy conservation equation, I am getting v square equal to v0 square minus 2gr 1 plus cos alpha, and therefore putting the value of v square from here, which is rg by cos alpha, I am getting v0 square equal to 2gr plus rg by cos alpha plus 2gr cos alpha, right? Now I'll be taking this gr as common, So I'm getting v naught square equal to gr under bracket 2 plus 1 by cos alpha plus 2 cos alpha. Now it is very clear that gr is fixed. It is not going to change. The wooden log, the radius of wooden log is already given to you. The value of g is fixed, as we know. 2 is again a fixed value, a constant value. So in order to minimize v naught square, we need to minimize this, right? 1 by cos alpha plus 2 cos alpha. Okay. So now if you want to minimize this term, you can also use differentiation, maxima minima, that conventional way. But what I have used is, we know that arithmetic mean is greater than or equal to geometric mean. So I am using this funda in order to find this out. So assuming or taking 1 by cos alpha is a and taking 2 cos alpha is b, I can say that arithmetic mean a plus b by 2 must be greater than or equal to geometric mean, that is root under ab. So now from here I'm putting the value of a, which is 1 by cos alpha, b is 2 cos alpha, greater than or equal to twice of root under ab. So a is 1 by cos alpha and b is 2 cos alpha. So this cos alpha will get cancelled out, and I'll be having 1 by cos alpha plus 2 cos alpha must be greater than or equal to 2 root 2. Alright. Now just put this thing here. I'm just putting this thing over here. What I'm getting is v naught square must be greater than or equal to gr under bracket 2 plus 2 root 2. Alright, so v naught must be greater than or equal to root under gr under bracket 2 plus 2 root 2. That means the minimum velocity that is required is root under gr under bracket 2 plus 2 root 2. Alright, so this is what we are getting as minimum speed required if we consider the case 1, right? If we consider the case 1. But we'll have to also compare with the minimum velocity required if we are considering the case 2, right? So I'm not doing that in this video because I've already uploaded that video almost a year ago. So you can go and watch that out. In that case 2, the minimum requirement comes out to be root 5 rg. Alright, while in this case what I'm getting 2 plus 2 root 2, that means it is coming something around 4.82, right? Root under 4.82 rg. So definitely this is lesser, right? So finally I'll be concluding that the minimum velocity of projection or speed of projection required to clear that wooden log of radius r is root under gr under bracket 2 plus 2 root 2. Alright, so hopefully this helps you out in your journey of understanding and learning physics. So thank you so much.